Hello students. Today we are going to continue pursuing our study of solving algebraic equations. Before we get started, let's review two concepts from yesterday. One, what makes an equation different from an expression? An equation must have an equal sign in it and then something that it equals, right? It's a complete sentence, if you will. It's a complete thought. It has an equal sign in it. That's what makes an equation different from an expression. An expression does not have an equal sign in it. X plus 2. We could fill that in. Whatever x is will make a difference as to what it's equal. But if we say x plus 2 equals 7, there's only one thing that can answer that question, and that, of course, is 5. So that's what makes an equation different from an expression. So try to keep that thought in your mind because that will be important as we move forward in math. The second thing is we talked about two rules for solving algebraic equations yesterday. The first rule, do you remember? Or look in your journals. The first rule was if you do it to one side of the equation, you also have to do it to the other side of the equation, right? In order to keep them balanced, remember we're thinking about that scale and balancing and our equations being balanced. So in order to keep it balanced, whatever we do to this side of the equation, we also have to do to this side of the equation. Whatever we do to this side of the equation, we also have to do the same thing to this side of the equation. Okay, so that is what we want to think about as our number one rule for solving algebraic equations. Our number two rule, and the goal for doing something to each side of the equation, is to get the variable on its own. Isolate the variable, right? We want to isolate the variable. So we're gonna look at some really simple problems today. You could solve these in your head. I know you can. That's great. That's not the purpose of what we're looking at, okay? So don't check out and say, oh, I know the answer to that. That's not going to help you. I know you know the answer to that. I need you to see the steps that get us to the answer so that when we get to more difficult or complicated problems that you can't just look at and go, oh, I know the answer to that. You know how to solve for it, okay? So open up your not your literature journals, open up your math journals, please, to your notes from yesterday. We'll just continue those if you would like to, or turn to a new page. And let's label the first one number 8. Should just be continuing on from where we left off yesterday. But number 8, it says x plus 8 equals 19. So get that written down. Now, I know you can figure this out in your head. It's not hard. I get that. But remember, that's not the point of what we're doing here. I'm going to show you two different ways that we can go about solving for x. Okay, two different ways that we can go about solving for x. And I would like you to write both these ways, take notes on them in your math journal. Write them both down and take notes on them. All right, so the first way is we can use a fact triangle like we've done in the past to find our fact families. So if we turn this into a fact triangle, right, remember we can add across the bottom and we can subtract going down. So we're adding x plus 8 equals 19, right? Now we can write our 4 facts that come from this. We can say x plus 8 equals 19. We can say 8 plus x equals 19. We can say 19 minus x equals 8. And we can say 19 minus 8 equals x. Now we did this before. We did this way back when I first sent you home from school. When we first didn't know if we were coming back or not, we did these fact family sheets. And then my question always was, which one is going to be the most useful in solving this problem? Well, we look at this, and of course, see, x is over here by itself. Remember, that's our rule number 2, to isolate the unknown. So x is over here by itself. So this one's the most useful for solving the problem. We can simply do 19 minus 8, which equals 11. So x equals 11. So that's how we can use our fact families or our fact triangle to solve for it. Here's the other part though, when we talked about doing something to both sides. This is what that looks like. I'm going to erase this. So if you need to, make sure you've paused the video and gotten it all written down. All right. We can manipulate it without using the triangle as well. okay? Remember when we had it on the scale yesterday and it was balancing, if we took some out from this side, as long as we took it out from this side, it stayed balanced, right? That's that idea of doing the same thing. So when we're looking up here, we know our goal, our rule number 2, our goal is to isolate the variable. So we need to get rid of this 8, right? So x plus something equals x, right? We want to get rid of this. We want it to just go away. So when we're talking about addition or subtraction, when we want something to go away, we think we want to get it to 0, right? So we're adding 8 to it. How do we get rid of that 8? We subtract 8 from it, minus 8. So we just have x plus 0. Well, x plus 0 is simply x, right? Okay, we've done it to this side. We have x all by itself. We took 8 away from this side. So we also have to take 8 away from this side to follow our rule. If we do it on this side, we must also do it on this side. So we subtracted 8 over here. So we're going to subtract 8 over here. 19 minus 8 equals 11. And we are left with x equals 11. Okay? That might seem like an awful lot of work to do a problem that you could have solved just by looking at the problem. That's okay. It is. We would not typically have to do this much work for this type of a problem. But what if your problem was 2x plus 7 over 23 minus x plus 6 divided by 2x equals 42? Is that a problem? You can go, oh, I know the answer to x. Most of us, not. Maybe if you're a genius, maybe if you have a computer in your brain, possibly. But most of us can't do that. So we would have to know how to go through the steps to get x all by itself, to isolate it, which is what we just did here. Okay, let's do it again. Number 9. Again, I know you can solve this by looking at it, but we're going to go through the steps to solve it. Particularly, we're going to go through these steps here because we've already practiced writing that fact triangle. So we're going to practice this moving numbers around, isolating, and our goal of isolating that variable. So f plus 5 equals 14. If we're adding something, in order to get rid of it, we need to get that 5 to equal 0. We need it to be f plus 0. So in order to get rid of a positive 5, we're going to subtract 5 from it, minus 5. All right, so now we just have f, because that's f plus 0. If we do it to this side of the equation, we must also do it to this side of the equation. So we do 14 minus 5, which equals 9. So now we have f equals 9. Make sure you're taking these notes. Make sure you're writing this down because I want to see all this in your math journal when you submit me these pictures at the end of today. I am going to ask for pictures of your notes because I want to make sure you're taking them. So f equals 9, right? We balanced the equation by isolating our unknown. We isolated the variable and we got f equals 9. Okay, for number 10, I want you to take a stab at it before I do it. 26 equals g plus 11. No, I don't want you to just write the answer down on the page. I want you to show me the steps in order to isolate our unknown, our variable, which is g here. So show me the steps that you would go through to isolate g. You can pause the video here and do that now. All right, here we go. We need to get g by itself. We're adding 11 to g, so really we want to add 0 to g. So in order to get down to 0 from 11, we're gonna subtract 11, and that gets us to g. If we do it to this side of the equation, we also must do it to this side of the equation. So we're going to subtract 11 over here, and that gets us down to 15. And so we have 15 equals g. All right, go ahead, show me the steps for numbers 11 and 12. 11 is up here. It says w minus 6 equals 10. 12 is here. It says z minus 9 equals 21. Again, I'm not worried about the answer. Yes, I do want you to get the correct answer. My goal is for you to show me the steps. So it's not just solving the problem, it's showing me the steps to isolate that variable, please. Pause the video, show me the steps to isolate the variable, come back, we'll check it together. Okay, 11. W minus 6 equals 10. Our variable's over here. We need to get rid of a negative 6. How do we get negative 6 up to 0? Well, this time we have to add 6 to it, right? This is why we practice that adding and subtracting negative numbers. We were down here on the number line. We needed to get up to 0, so we're going to add 6 to it to get up to 0. So we get W equals, if we added 6 to this side of the equation, we must also add it to this side of the equation. Plus 6, we get 16. W equals 16. Number 12, Z minus 9 equals 21. We were 9 below 0 on the number line, so we need to add 9 plus 9. Those cancel each other out. We get 0. Z equals, we're going to plus 9 over here. Oops, we're not adding 9 down here. Z equals 30. Now, the last step in solving for algebraic expressions, or equations, is always to take your answer and go back, plug them in, make sure it makes the equation true. So let's double check. Z equals 30. 30 minus 9 equals 21. W equals 16. 16 minus 6 equals 10. Let's go back down here. 26 equals G plus 11. 15 plus 11 equals 26. Up here, F equals 9. 9 plus 5 equals 14. And up here, X equals 11. 11 plus 8 equals 19. Very good. All right, so that is how we solve for our variable. We solve our algebraic equation when we're adding or subtracting. But when we are multiplying or dividing it, we have to think a little bit differently. So I'm going to erase these, put up the multiplying and dividing ones, and we will look at those. Like with adding and subtracting, our goal remains exactly the same. We need to isolate the unknown, isolate the variable. Like with adding and subtracting, our number one rule is the same. If you do it to this side of the equation, you also do it to this side of the equation. If you do it to this side of the equation, you also have to do it to this side of the equation. Those rules don't change, but there's one thing that's a little bit different. With adding and subtracting, we are thinking, oh, we need to get our number down to 0 because x plus 0 or m plus 0 or q plus 0, those all just equal q. With multiplying and dividing, that's a little bit different because x times 0 doesn't equal x. What does x times 0 equal? Well, x times 0 equals 0. Any group of 0 is always going to be 0. Even if you had 222 groups of 0, you still just have 0. So it's not 0 that we're seeking to get our numbers to this time. What do you think we need to get our numbers to? What times x equals x? Or x divided by what equals x? They're the same answer. X times 1 equals x, or x divided by x equals x, right? And so our goal here, I'm sorry, I said that wrong. X times 1 equals x. X divided by 1 equals x, right? So our goal here is to get our numbers down to 1, not 0 this time, because that would throw us off. So let's look up here. Again, remember, I know you can solve these off the top of your head. You can look at them and figure out the answer. That's not the purpose of what we're doing right now. So what I want you to do is still show every step of the way in your journals, and you're going to take a picture of it at the end of the lesson and submit it for credit today. So make sure that you are following along and writing each of these steps down. Okay? All right, number 13, 3x or 3 times x equals 27. Well, let's practice. Let's just be refreshed and put it into a fact family triangle first. So just like with addition and subtraction, the bottom of our triangle is what we would call commutative, and the edges are division. So 3 times x, I should have put a dot here, equals 27. So we can write our 4 fact families. We get 3x equals 27. We get x3 equals 27. Yes, this is a way to write the multiplication problem, it's not a proper way to leave a number. So make sure you never leave a number x3. It's always the coefficient first followed by the variable 3x. All right, so we can do 27 divided by 3 equals x, and 27 divided by x equals 3. So which of these, numbers 1, 2, 3, or 4, is the most useful for solving this equation? 1, 2, 3, or 4? It is 3. 27 divided by 3 equals x. We know 27 divided by 3 equals 9, and so we know that x equals 9. So there's how you can use your fact family triangle to solve that, like we practiced earlier in the year. But now let's practice doing it by isolating our variable. Okay, in order to get x by itself, what do we need to do to the 3? Your first thought might be, well, we subtract 3. But if we're multiplying here, can we go ahead and subtract? We can't, because that's not what it's saying here. So in order to get x by itself, we need it to be 1x. So we would divide by 3. 3x, it would look like this. Well, right here. It looks like this, 3x over 3. Well, we can simply cross-reduce that, right? To 1 over 1, 1x over 1, which just equals x, right? So we're going to divide our 3x by 3, and we get x. And then, of course, we're going to divide 27 by 3, and we get 9. So x equals 9. We isolated our unknown by dividing this by 3, so it equals 1x, or just x, equals, if we did it to this side, we also did it to this side. So 27 divided by 3 equals 9. Remember, even though it's a little bit harder to show this on a scale, and so it was harder for me to demonstrate this for you yesterday, it still follows the same rule in that scale. If the scale is balanced to start with, which the equal sign tells us it is, if we do the same thing to this side that we do to this side, we end up with the exact same thing. It's still equal. It's still true. And so that's why we always do, even if it's division and it's a little bit harder to picture in your mind, dividing as a possibility, it still remains true that whatever we do to this side of the equation, we also do to this side of the equation, and our scale remains balanced. It remains equal. All right, let's look at 14. 6a equals 42. Well, what do we need this to equal? We need it to just be a on this side. So in order to get rid of it, we're going to divide it by 6. We can cross those out. Divide it by 6. And what we are left with is a equals 7. Something you should start to notice, as you could have noticed it earlier when we were adding or subtracting, and you'll notice it here when we're multiplying and dividing. We do the opposite of whatever function is here, right? So let's look at number 15. 65 equals 13 times b. Remember earlier, if it said x plus 7, we subtracted 7. If it said x minus 7, we added 7 to it because it just has to get to 0 or just to x. Same here, if it tells us to multiply, we're going to divide. We're going to do the opposite of the function in order to get it by itself. So 65 equals 13b. We're going to divide this by 13, and we cross-reduce there. So now we're left with just b. If we did it to this side, we also must do it to this side. So we're going to divide 65 by 13. 65 divided by 13 equals 5. So 5 equals b. Okay? We divide because we want it to be 1b. And 13 divided by 13 equals 1, and 1b simplifies to just b, right? So we're going to do the opposite each time. Okay, now we have some division problems over here. So if I just told you we're going to do the opposite to solve our problem, what are we going to do? What function are we going to use to solve for 9? It looks like I wrote that right in the glare on the camera. I don't know if you can see it. It says m divided by 8 equals 9, or m over 8 equals 9. So if we're dividing up here, in order to get m all by itself, what are we going to do? We're going to multiply. So if we have m over 8 equals 9, we can multiply times, right, 8 over 1 times m over 8. Well, then we just cross reduce. 8 over 8 and 8 over 8 both equal 1. And so now this just equals m. But if we multiplied over here, we must also multiply over here. 9 times 8 equals 72, right? Equals 72. And then we can double check that our problem is true by substituting it back for the beginning. So we had m divided by 8 equals 9. 72 divided by 8 equals 9. And so m must be 72. 17, go ahead, try 17 on your own. Show me all the steps. It's not about, can you just pop the solution for n in there? It's, can you show me the steps to isolate n and then solve for m? So pause the video, show me the steps to do that, unpause the video, and we'll keep going. All right, so we're dividing by 7, so we're gonna do the opposite of that and multiply by 7. So times 7 over 1, our 7's cross reduce, and we're left with just n over 1, which equals n. But if we multiply by 7 over here, we must multiply by 7 over here. And 12 times 7 equals 84. 84 equals n. Right? We double check that, plug it back in. 84 over 7 equals 12. Is that true? Yes, it is true. And so we know that that is our solution for n, okay? So what you need to remember as you're going through your assignment today is, first of all, when you finish, when you find what you think is your solution, plug it back in. Make sure it really is your solution. Make sure it works and it makes the equation true when you plug it back in. Second of all, don't rush. They look easy, but they might twist your brain a little bit more than you think they will. So don't rush through it. Show your work as you need to. And today, I think you are completing numbers 1 through 12 on page 12. So lesson 8.1, numbers 1 through 12, and we will correct those tomorrow. All right, talk to you later. Bye.